Many years ago, a series of books on different geometrical properties was written. Interesting properties recorded in the books included those on circles. Let's look at one of those properties today. That the perpendicular bisector of a chord of a circle passes through the center of the circle. Let's first look at this circle with center O. Draw a chord CD in this circle, and draw a straight line through the center of the chord such that it is perpendicular to CD. This straight line is called a perpendicular bisector of chord CD. To refresh your memory, bisect means to cut the chord into two equal parts. And bisector refers to this line that did the cutting. Let's shift D to vary the length of the chord. What do you notice about the perpendicular bisector when the length of the chord varies? Now, let's try changing the position of chord CD. Again, what do you notice about the perpendicular bisector when the position of the chord varies? The perpendicular bisector of the chord always passes through the center of the circle. Now that we know this, does the center of this circle lie on PQ? PQ is perpendicular to AB and passes through point X, which is the midpoint of chord AB. So, PQ must be the perpendicular bisector. By the property, the center of the circle does lie on PQ. Now, look at this circle. Which line passes through the center of the circle? Is it CD? Or PQ? Or ST? All the lines bisect chord AB. They are bisectors. However, notice that they are not perpendicular to AB. Thus, none of the lines will pass through the center of the circle. Did you get it right? What about this circle? Does the center of the circle lie on PQ? PQ is perpendicular to AB, but it does not cut AB into two equal parts. So, no, PQ will not pass through the center of the circle. Remember, the line must be perpendicular to the chord and bisects the chord for it to pass through the center of the circle. Now that we know this property, go on and discover the other properties of circles.